Welcome to the last proof that I will be instructing you on. If two angles are vertical, then they are congruent. Now this is something we've said often, but we've never actually proven it. Let's look at it logically speaking. So now, let's say we have two angles, right here. Now before, we learned that if you have an angle here that measures 30 degrees, we know the next angle right next to it. So if this is 30 degrees, what would this angle right next to it be, and why? Yes, Junior?
150.
150. Thank you, behind the cameraman, who is also known as Junior. So now, because these two angles are a linear pair, we've learned that they had to be supplementary. 30 and 150 give us 180. But not only do these two add to 180, these two also happen to add to 180. So if this is 150, what would this angle right next to it be? Yes, Nathaniel?
Would it be 30 degrees?
It would be 30 degrees. Interesting. This angle and this angle, which are vertical angles, were congruent. That's one example. That's just an instance. We need to do it again. So let's take another vertical angle. So let's say we have a 70-degree angle here. If this is a 70-degree angle, and I see that these two angles are a linear pair, and I've proven something about linear pairs, what would this angle be now? Yes, Nathaniel?
Would it be 110?
It would be 110 degrees. So I know that because this and this is a linear pair, together they must make 180 degrees. But also, if this and this make a linear pair, what would this one have to be? Yes, Nathaniel?
It would be 70 degrees.
It would be 70 degrees. That is so interesting. It seems that this is supplementary to this, and this is also supplementary to this. Interesting. So let's prove why if two angles are vertical, then they are congruent. Keep in mind, I only did two examples. Are two examples enough?
No.
No, because it could be a coincidence. Let's do a third one to establish a pattern. So we want to prove that this angle and this angle end up being the same thing. Let me pick a number for this angle. 20 degrees. I think I've seen that number 20 degrees before. Let's see, if this is 20 degrees, what would this be and why? Yes, behind the cameraman?
160 degrees.
And why is that, behind the cameraman?
Aren't they a linear pair?
They are a linear pair, and we've proven that linear pairs have to be supplementary. So this and this have to make 180 degrees. What would this angle have to be, behind the cameraman?
20 degrees.
Why is this 20 degrees, behind the cameraman?
Because it's a linear pair with 160 degrees.
It is another linear pair with that right there. You have something to add?
Would that make 20 degrees and 20 degrees vertical angles?
They would be vertical angles, and they're congruent. One example, which is an instance. Second example, which might be a coincidence. Third example makes it a pattern. So let's see if we can prove it deductively. So now we say if two angles are vertical, then they are congruent. What word might we have to define to help clarify things? Yes, Nathaniel?
Vertical.
Vertical angles, because we might not know what vertical angles are. If two angles are vertical angles, that means they're created when two lines intersect. And sometimes it may be best to draw a picture to help our proof. Here's Here's my first line. No vertical angles here. Here's my second line. Now we have some vertical angles. But which ones are the vertical angles? If this is 1, 2, 3, 4, which angles are vertical angles in this picture? Yes, Nathaniel?
Would angles 1 and 3 and angles 4 and 2 be vertical?
That is correct. It's either you say angles 1 and 3, or you say angles 2 and 4, because it says they are the opposite angles created when two lines intersect. So let's focus on angles 1 and 3 for a moment. We want to prove that angle 1 is congruent to angle 3. That's what we are proving. So now, when the two lines intersect, not only did they create vertical angles, but they also created what other kind of angle relationship? Yes, Nathaniel?
Supplementary angles?
Well, supplementary, why? Why did it create supplementary angles? Because it also created what behind the cameraman? So not only did it create these vertical angles that are opposite each other, but it also created these two angles, which are called, yes,
Linear pairs.
linear pairs. So when the two lines intersected, it created vertical angles, but it also created linear pairs, which Nathaniel said are supplementary. So if two angles are vertical, they're the opposite angles created when two lines intersect. When the two lines intersect, it created linear pairs.
Make sure you write this down, kids.
So angle 1 and angle 2 are a linear pair. LP for short, linear pair. Angle 2 and angle 3 are LP for linear pair. Angle 3 and angle 4 are LP for linear pair. And last but not least, angle 1 and angle 4 are LP for linear pair. So we have one linear pair set, two linear pair set, three linear pair set, and a fourth linear pair set. So when the two lines intersected, it created four linear pair sets. There they are there. This is one linear pair set, second linear pair set, third linear pair set, and the fourth linear pair set. So when two lines intersected, not only did they create vertical angles, but they also created linear pairs. 1 and 2 are linear pairs, 2 and 3 are also linear pairs, and I want to prove that angle 1 and angle 3 are congruent. Well, if they're linear pairs, what did we already prove about linear pairs? What do we know about linear pairs? Yes, Nathaniel?
Linear pairs form a line.
They do form a line, and since they form a line, that means they must be what to each other? Starts with an S.
Supplementary.
Supplementary. So since angles 1 and 2 are linear pairs, they must be supplementary. So I'm going to write linear pairs are supplementary. And we don't need to reprove it because we already did. Linear pairs are supplementary. Linear pairs are supplementary. Now you may ask, but wait, Ms. Banner, don't we need to define linear pairs and supplementary? The answer to that is no, because if we look at the original conjecture, supplementary wasn't part of it and linear pair wasn't part of it. So we don't have to define it. The only things we have to define is anything that was previously stated in our conjecture. So linear pairs are supplementary. Since angles 1 and 2 are supplementary, are linear pairs, they are supplementary. Since angles 2 and 3 are linear pairs, they are also supplementary. This means that angle 1 is supplementary to angle 2. And angle 3 is also supplementary to angle 2. Angle 1 is supplementary to angle 2. And angle 3 is also supplementary to angle 2. In our previous lesson, we learned about when one angle is supplementary to one angle, and that angle is supplementary to another angle, we were able to draw a conclusion. In our last thing, I think we said if A was supplementary to B, and B was supplementary to C, what did we conclude about A and C in our last video? Yes, behind the cameraman?
A and C are equivalent.
A and C would be equivalent. So now if 1 is congruent, if 1 is supplementary to 2, and 2 is supplementary to 3, Nathaniel, what does that mean about angle 1 and angle 3?
They're equal.
They're equal in measure, which makes them congruent. So now since we said, since angle 1 and 2 are linear pairs, they are supplementary. Since angles 2 and 3 are linear pairs, they are supplementary. This means angle 1 and angle 3 are both supplementary to the same angle. Since every angle only has one supplement, that means angle 1 and 3 must be the same number. Therefore, and you restate your conjecture. Now, someone may say, wait a minute, Ms. Banner, I'm still confused. So let me show you mathematically how this also plays out. And I'll just write the therefore statement. If two angles are vertical, then they are congruent. So now let me show you this mathematically. According to the diagram, I already see that angle 1 and angle 2 are supplementary. So that means that the measure of angle 1 plus the measure of angle 2 equals 180 degrees because they're a linear pair. And I also see that angle 2 and 3 are a linear pair, so the measure of angle 2 plus the measure of angle 3 equals 180 degrees because they were also a linear pair. Since they both equal 180,
Doesn't that mean that measure 2 and 3 is equal to measure 1 and 2?
that is absolutely correct. So the measure of angle 2 plus the measure of angle 3 equals the measure of angle 1 plus the measure of angle 2. Because if they're both 180, then these two must both be equal as well. Now, what else can I do behind the cameraman?
Doesn't that also mean you can subtract both measures of angle 2 because of the...
What is that? If I can
What was it called
subtract on both sides,
The subtraction property of...
it is the subtraction property of equality since I'm going to subtract this measure on each side. So when I subtracted the measure of angle 2 from here and subtracted the measure of angle 2 from here, I am left with the measure of angle 3 equals the measure of angle 1. And this was what I was trying to prove in the beginning. Since the measures are equal, the angles must be congruent. Good job, boys and girls. But before you go, let's see how we use all of this in one example. Can I erase this? Do you have this written down?
Yes, Miss Banner.
Okay, it's coming off the board down.